we will learn another traversal which is also quite important. So let's say there is a tree now, 1, 2, 3. So there is a traversal called as level order traversal. This is also called as BFS, breadth first search. Why? Because it doesn't act in depth. So all the 3 traversals that you saw before, and especially pre-order traversal, it worked in depth, right? So it started from here and dig deep before it came to the same level again. So never ever it so happened that the nodes of the same level are getting printed in the consecutive manner. Level order does it. So level order prints the nodes level by level. So first it will print everything of level 0, then everything of level 1, then everything of level 2, and then everything for level 3. And that too in left to right manner. So there is no fight between level I and level I minus 1, because level I will start printing after level I minus 1 only. But if you focus your attention on level I, for that the printing will happen from left to right. So the order will be 1, 2, 3, 5, 4, 6, 7, 8. This is the level order traversal of this tree. So can you suggest a way to perform this traversal? It's easy because we have just finished some important data structures and that would be helpful. Queue data structure, how many of you feel queue would be helpful? Yes, because here that last in first out philosophy does not help. Here whatever are the first few nodes from the top to bottom, those should be printed, and whatever are the last few nodes from top to bottom, those should be printed later. So it is like first in first out. Okay, how many of you can write code for this? So you will take a queue, and you know that queue is a first in first out data structure. You will know that the first node to be printed will be the root, so you start with the root, and then both your front and rear are over here only. So let's say this is your front, this is your rear. So front is that back pointer and rear is this side. Okay, now you take it out, pop it, and then because you know the left child to be printed before right child, so first check the left child exists, yes. If yes, push it, and check right child exists, yes, push it. So now this is your rear, this is your front. Again you pop, you check, does the left child exist? No, so do not push. Does the right child exist? Yes, push. So now your front comes here, rear comes here. Again the same thing. So now you are at this 3. So for 3, does the left child exist? No. Does the right child exist? Yes, push it. So now your front comes here, rear comes here, this is gone, and this is how it would go on. Now you're at 5, does the left child exist? Yes. Does the right child exist? Yes. Push them, get rid of this, so now your rear is here, front is here. So do you see that 1, 2, 3, 5, 4, 6, 7, and similarly at 4 you will print that 8, and eventually your queue would be empty whenever you are popping the leaf nodes, because leaf node will neither have a left child nor a right child. It is a very simple implementation. So you start with a queue, simple queue of nodes. So it will be a queue of node star. Okay, because you have to know for a node what is the left and right. If you just have a queue of integers which are values, you cannot know what is left child and right child. Same was the case with stats also. So you have to have a queue of node star and initialize your queue with root. So queue dot push the root. And now that approach comes, so while not of queue dot empty, you can get your job done. So just pop the top of the queue, pop this end of the queue, rear end of the queue. So do queue dot pop, but before that you need to do queue dot back. I think this is called as back. Please check it. Is this rear or back in your language? And then you get this node n, and then do queue dot pop, and then you print the value associated with n, and then if same thing, if right child exists, push it, and similarly if left child exists, push it. This is how you go on, and you will be able to have the job done. Can you comment on the time complexity? Order n, right? Because any node is either being pushed once or being popped once, right? So you're spending two units of time at any node, so that is order of 2 into n, which is back to order of n. Extra space, I would say be a bit cautious before you comment on the extra space. Yes, how many of you agree with Shivani? She is saying maximum number of nodes at any level. if you take a look at this queue, although that is not exactly correct, but I'll tell you how you can comment on the space complexity. Space complexity would be the maximum size of the queue at any point of the time, and maximum size of the queue is the distance between rear and front, because the moment you push something, that memory area is freed in an STL queue, whatever you are using, right? Because your queue is dynamic. So what are the maximum number of levels whose nodes can exist in a queue simultaneously? I repeat it. What are the maximum number of levels whose nodes can simultaneously exist in the queue? It should be 2, right? Because it can very well happen that, see, whenever you are pushing something in a queue, whatever you are pushing belongs to level I, and whatever made this push possible was of level I minus 1. So one thing is guaranteed, that it's sure that nothing of level I minus 2 will be there. Because if level I minus 2 was there, I would not be pushing level I would be pushing nodes of level I minus 1. So it can never happen that more than 2 level nodes are simultaneously there in my queue. So in the worst case, what could happen is that, let's say some of the nodes, let's say almost all of the nodes of level I minus 1 are also there, and almost all of the nodes of level I are also pushed. So if you sum up the number of nodes at level 0, level 1, level 1, level 2, level 2, level 3, then what will be the maximum of that? That would be the maximum size of the queue that could be possible. It would never be greater than that. Now I'll ask you another question. That question is, here you were able to print this entire thing in a single line, right? You did not press enter anywhere. You did not put a new line anywhere. But now the question is that I want to print them level by level in a new line. When I say that, level 0 should come in line 0, level 1 should come in line 1, and last level should come in last line. So 1 should come in this line, then 2, 3 should come, then 5, 4, and then eventually 6, 7, 8 should come. This is the manner in which I want to print them now. Output is the same, just the format of the output is different. Okay. So do you understand the expectation of the question, guys? Yes or no? Others? Yeah. So if you understand it, can you comment on how to make this possible? How many of you can do it? Just type in yes or no. A very, very simple change can ensure you can do this. Now we need to push null. If you push null, I don't think that null would help, because what if there is a complete tree? Okay, so Ravi, that will not help. So Dilip is saying store pair. Okay, so how many of you feel storing pair will help? And by pair he means to say that the first element of the pair will be node and second element of the pair will be level. Will that help, guys? Yes or no? If you store the levels along with the nodes, that will always help, right? Because the entire problem was to know that whether this node belongs to the same level or belongs to the new level, right? This was the entire problem. And if I have a pair, that solves it. So Ravi, why I think your approach would not work would be because if you have a, let's say, tree like this, 1, 2, 3. I mean, how would it work? So after 1 you push this 2, 3, and after 2 you push this 4, 5. Till now null has not been pushed, but you would want 1 to come in a separate line, 2, 3 to come in a separate line, and 4, 5, 6, 7 to come in a separate line. So I'm not really sure how would that work. And the point that Dilip is saying is very simple. He's saying that, hey, whenever you push a node, push it with its level. So let's say you push 1, you push it with its level. Now guys, tell me one thing. Whenever you push its children, and let's say the level of this is L, what will be the level of its children? It will be L plus 1. That's simple to say, right? So what you can do is, after 1, you can push this 2, 1, and you can push this 3, 1. And now you have gotten rid of it. So how does this approach work? This approach works in this manner, that the moment you see that the level of this thing is bigger than the level of previous node, what does it mean? It means that now you should start a new line. So what I can do is something of this sort, that I can initialize a level equals to 0, and first Yeah, let me do it again. First I'll push this 1 0, and when I seek this element, when I seek the rear end of the queue, if I check that this level is greater than this level, then I'll begin a new line. Otherwise I'll continue printing in the same line. So I print it here, and after printing it here, I'll pop it and then I'll push its children, which are 2 1 and 3 1, and the level has not changed. Now again I'll seek this. I see that the level of this is higher than the level of this. That means that this 2 should be printed on a new line, right? So now I'll print it on a new line, and I'll also update the level. And then I'll push its children. Its children are, what are the children of 2? 4 and 5, yeah. So now I'll have 4 and 5 coming in, their levels being 2 and 2 each, right? Now again, when you seek this thing, rear end of the queue, you see that this level is same as this level, so you will print in the same line. And then you will push its children. And then again, when you come here, you see that, hey, this thing is greater than this, so you will start a new line, okay? So 4 and 5 and 6 and 7, all of them will come in a new line. So using a pair, you know where to break the line. But what is the con of this approach? The con of this approach is that you are having to do it with a pair. Can I do it without this pair? Yeah, so there are many workarounds with that. I'll suggest one very simple way. Okay, so just listen to my way, guys. It's easy to implement also and easy to understand also. So what you can do is something of this sort, that here what you are doing, in each iteration, there is one pop and 1 or 2 or 0 push, depending upon the node to be popped had how many children. This is what is happening in this approach. Now what I am going to say is something like this, that hey, inside this while loop, I'll not just perform one pop, I might perform so many pops, and the number of pops that I'll perform will be equal to the iteration number of this while loop. In other words, when the iteration 0 is happening, I'll pop all the nodes of level 0, and once that is done, all the nodes of level 1 would already have been pushed. Similarly, in the next iteration, I'll pop all the nodes of level 1, and by the time it happens, all the nodes of level 2 would already have been pushed. Let's understand it. It's easy to get. So let's say this is the tree that I have, okay? Forget about this tree. Once I have this tree, I can initialize my queue. I have 1 in it. So when the first iteration is happening, how do I know that how many elements are there which are belonging to this level? Because in the process of popping, my front end is changing, right? The front end is changing. So what you can do is, the moment you enter this while loop, just figure out your current value of rear and current value of front. Once you have figured out the current value of rear and front, just pop everything from rear to front. So you will pop everything from here to here, and you would have pushed 2 and 3. And once that first iteration is over, you have printed this one, and when that iteration is over, just give a new line, okay? So now again, when you come back to this while loop again, now you will see that this is your front, this is your rear. So pop everything from rear to front by printing them in a new line, and once you have done that, everything of the new level would automatically be there in the queue again. Now again, you measure your front and rear and then pop everything in the new line, right? It's just the implementation based thing, just the implementation has to slightly change, right? That now, instead of doing this thing, see, earlier the number of iterations of this while loop was more. Now the number of iterations of this while loop will be less, but the complexity will be same, because there is a new while loop inside, which is not just doing 1 and 0, 1, 2 work, but it is popping many things and pushing everything off the new level. I want you to try one thing on your own, that is called as zigzag level order traversal. Zigzag level order traversal. What does it mean is that you print level by level, but first level is print from here to here, then next level is printed from here to here, then next one is printed from here to here. So the output of this will be 1, then 3, 2, then 4, 5, 6, 7. And let's say I had a 9 and 11 and 13, just this much. Then again this level would have printed from here to here. So it would have been 13, 11, 9. This is how it would go on and on. In every iteration we empty the queue, and when it's empty we change the level. You do not empty the queue. I said that whatever iteration you are making, and when I say, see, there will be one while loop inside also. Do you see that? Because now you are going to make more than one pops, so there will be one while loop inside also. So whenever you are making an iteration, just record your front and rear and store that in a variable x comma y. And then from x to y, which is you for y minus x plus 1 times, you perform pop and push, pop and push. And all those pop and print have happened in the same line. And once that is over, then you move on to the next level. Okay, so this is your homework. Okay, think of it. How can this be done? And that's it.